Hello, my name is Nobuaki Tanaka from Gaio Technology Corporation. We have Hisashi Yomiya and Kiyoshi Ogawa as co-authors. The title of the presentation is a method to support the accountability of safety cases by integrating safety analysis and model-based design. First of all, we would like to say thanks to the staffs and secretariats who held DECSoS and safety comp under this very difficult situation in the world. We would like to express our gratitude to the reviewers who gave us essential comments to improve our proceeding paper and the activity. Now let's go to the overview of the presentation. We defined our objective as to visualize safety analysis result in a more understandable way to ensure that safety mechanisms mitigate the effects of failures. One solution to achieve the goal is to create a model that integrates safety analysis results with system design and divide the model into diagrams according to reviewers' concern. As a result of our activity, the method could visualize how the safety mechanism protects against the effects of failure on internal block diagrams. We could visualize the result of FMEA MSR with the proposed method. In the activity, we found that in the case study, we could understand that the safety analysis result interact across the boundaries of the system design elements. I will explain these activities in turn. First of all, I want to explain our issue and objective. Our understanding of the situation of the embedded system development is that the system is getting more complex and larger. And that kind of huge development requires huge organization. And communication in the huge organization, we mean between designers and analysts and reviewers is becoming more important. And one issue, we think that one issue is exists in the situation. To communicate the result of safety analysis is becoming difficult. In particular, it is difficult to communicate how the safety mechanism of functional safety mitigates the effect of failures. We think that one reason is that increasing complexity and the size of product. But we think that the functional safety standards such as ISO 2662 and IEC 61508 requires independence of reviewers from the development team. Therefore, the independence is causes a complex situation. And in this understanding, from this understanding, we defined our objective as to facilitate the reviewer's understanding of the safety analysis results. And not only the interactive communication, like an interview or discussion, we want to facilitate the reviewer's understanding from the documents, diagrams, artifacts. We think that MBSA model-based safety analysis is a key technology for improving understandability of safety analysis artifacts. We found many recent research works of MBSA, and we think there are some categories of the MBSA, but in this, in our activity, we use the term MBSA as an abbreviation of model-based safety design. We mean a safety analysis method which utilizes model-based technology in a broad sense. This slide shows the next topic, the cause of the issue problems. One problem is that low cohesion of related information in safety analysis results. Reviewers' concerns are dispersed across several documents. And the second problem is that lack of graphical expression. We think that relationships between system model and fault model should be graphically expressed, and the sequence of failures effects should be graphically expressed. This slide explains the first problem, low cohesion. We think that information is dispersed across artifacts in the safety analysis results. Please see left-hand side of this slide. Information of failures behavior is dispersed across multiple artifacts. Some elements in the system design exist in system design and FMEA, and information about the effect of failure exists in FMEA and FTA. The relationship between them are expressed as identifier or traceability information, but we should trace those relationships to understand the whole structure of the safety analysis result. If it should be easier for reviewers to understand the information about a failure if they are presented in one place. If the information is divided according to a concern, reviewer's concern, and expressed in one diagram or one document, it should be easier for reviewers to understand. Another problem is graphical representation. We think that fault-free model is suitable for failure rate calculation and necessary for safety analysis and safety design. But the model does not express sequence of failures occurrence detection, that kind of effect of failure, sequence of failures effects. And the activity model is suitable for representing sequence of effects of failures. As you can see, the flow expressed by the arrows in activity model, activity diagrams. And another graphical representation is relationship. Visualizing the correlation between the system model and fault model will facilitate the understanding of failures behavior. The activity model is suitable for representing the correlation because the activity model's structure is similar to system design. So drawing the relationship between system design elements and the fault model will make it easier to understand the system's behavior when a failure occurs. But how can we get the activity model from our existing safety analysis result? We think that two possible sources exist. One is FMEA MSR. FMEA, which was introduced in AIAG VDA FMEA handbook published last year. FMEA MSR analyzes safety mechanisms of functional safety. Therefore, we can utilize the information about the safety mechanisms, including failure detection and mitigation and the effect. So we can utilize the information in FMEA MSR to construct the activity model. And another one is a FT diagram. If we intentionally construct, in order to investigate the possibility of converting an FT diagram into an activity model, we intentionally created an FT diagram that includes interactions and try to convert and import the FT diagram into IBD. This is a brief explanation about FMEA MSR. MSR stands for Monitoring and System Response. The FMEA MSR introduced in AIG VDA FMEA handbook published last year, and it analyzes failure causes and the customer operation conditions, and it considers whether or not failure mode are detected by the system. So the result of FMEA MSR includes the information about monitoring, system response, and the mitigated failure effect. And we think that those information can be used to construct our activity model. Next, we want to explain our solution, implementation of the solutions. First of all, we designed the notation of fault model. We think that we designed a notation that can display system model and fault model in one diagram. We think that SafeDML presented in last SafeML and SysML 2.0, which is under standardization, can be used in our activity, but they were not available in our activity. So we designed our own notation, but it's not special. If we can use notation which can express the system model and the fault model in one diagram, it will be sufficient for our purpose. The second solution is importing and converting and importing the fault model to a system model. We imported the FTA and the FML data into system diagram and integrated into a combined model, so we can get the model which includes a fault model and system model. And third solution is divide the combined model according to concerns. We think that one important concern in development, in a review, is the effect of failure. So we divide the combined model according to effect of failure. This is the first solution, meta model of the proposed design. When designing a UML system-related diagrams, meta models are used to express the design of the diagram. Design of the notation. Meta model abstract the logical structure of elements and the relationship between elements in the diagram, in the notation. And please see figure 2 in the proceeding. And we have system model in the meta model, but the system model follows the MBSE, and it is described in system development with using SysML, so it's not special. We put some logical elements in a system model, but they are very simple or standard SysML elements. And but right hand side, fault model, SysML doesn't contain fault model. Therefore, we have to add elements to describe the effect of a failure. We put failure mode, detection, and system response, and the effect of a failure. We also added the relationship between fault model and system model. As you can see, the 3 lines between fault model and system model. This is the diagram which shows how we converted and imported the safety analysis result into a system diagram. Let's go to the next page. The right-hand side of this slide shows the procedure to import elements and relationships described in each safety analysis result. And the left-hand side shows the procedure to provide relationships between different safety analysis results from traceability information. We think that in some cases, the relationship between the elements in different artifacts are expressed in traceability information. And in other cases, the relationships are embedded in safety analysis artifacts and the system design documents as semi-identifier. But they are not included in safety analysis results, safety analysis artifacts, and system design artifacts. Therefore, we have to provide the relationship between the component in different artifacts on the left-hand side of this slide. And we imported those information into a system diagram, and we can get the combined model, model of failure chain on the internal block diagram. And this slide shows how we converted fault tree model to activity model. As you can understand, the ordinary or usual fault tree diagram doesn't contain the information about the sequence of the effect of a failure. So we embed the kind of element in a FT diagram, and we defined that sequence of the effect of a failure shall be determined by the type of the element. So we can convert the fault tree model to activity model according to the kind of the element in a FT diagram. And the right-hand side of the slide shows the correspondence between system design and safety analysis result. When we use internal block diagram, we can we can provide the relationship between elements in those safety analysis results and the safety and system design. We can convert the we can provide the relationship between them. This slide shows the third solution, how to divide. We think that one important concern of reviewers and developers is the effect of a failure. So we provided a prototype software tool functionality which divides the combined model according to a concern, according to a failure. If the operator or the reviewer specifies one failure mode, the software tool extract the effect of a failure from the combined model and displays on the internal block diagram in the SysML. Therefore, we can get the diagram which is shown in figure 7. This is an example of our case study. Left-hand side, figure 7 shows the case when we use the FMEA-MSR information. Safety mechanisms and mitigated effects are visualized in conjunction with system design. And right-hand side of this slide shows the case which we added. We merged the information from our FT diagram, which was converted to an activity model. Detailed failures behavior imported from FT diagram shows how the failure propagates to safety, effect of a failure propagates to safety mechanisms. But the diagram is a little bit complicated and sometimes difficult to understand because of the complexity. So the reviewer or the developer should judge if the figure 8 is suitable for the review or figure 7 is preferable. This slide shows the conclusion of our presentation. With the proposed method, we could correlate the safety analysis results with the system design and visualize them. The diagrams created from FMEA-MSR results facilitate understanding that safety mechanisms mitigate the effect of failures. And we found that the diagram shows the result of FMEA-MSR do not show the effects of failures in detail in one-to-one correspondence with system design components. And monitoring system response and effect interact across the boundaries of the system design components. So there is a difference between the model of safety analysis and system design. We should consider how we should visualize or how we should handle this situation further. This is the future work of our activity. We should apply to larger system and product development because we conducted a case study, but this is not the product development, so we should investigate further. And the application to the entire safety analysis work should be conducted because we focused on the visualization and the improvement of the understandability, but safety analysis work can obtain the merit or the improvement from the this kind of MBSA technology. So we should investigate in this field. And the consistency among heterogeneous models, we mean safety model and system design model, should be considered further, as I explained in the previous slide. And this is an important topic in MBSA, I think. And this concludes our presentation. And thanks